In this video, we are going to introduce what a series is. So I want to motivate this with an example. Let's consider this sum, 1 plus a half, plus a fourth, plus an eighth, plus so on. So I notice that to get from one term to the next, I keep multiplying by 1/2. So the terms are getting smaller and smaller. I can write this in sigma notation, which you've likely seen before in calculus. This is the sum from n equals 0 to infinity, because it goes on forever, of 1/2 to the n power. Remember, the way this sigma notation works is you first plug in this value at the bottom here, n equals 0. Well, 1/2 to the 0, that just gives me my first term. If I plug in the next integer up, 1/2 to the 1, that's 1/2. If I plug in 2, I get 1/4, and then I get 1/8. And then I'm adding them up. That's what the sigma means, make a sum. So an infinite sum is called a series. So, when I'm adding up this infinite sum, we might wonder, well, isn't that just infinite? Or can it possibly be finite? So the way we find the sum is we look at what's called a sequence of partial sums, which I'm going to call S sub n. So the first partial sum is you just look at the first term by itself. The second partial sum, S2, is you take the first two terms and you add them together. You can simplify it, which is 3/2 or 1.5. Then S3 is the first three terms added together. That becomes 7/4 or 1.75. Then it's the first four terms added up, which is 15/8 or 1.875. So the terms are getting bigger. These partial sums are getting bigger, but kind of progressively smaller in terms of how much bigger they're getting. It turns out they actually have a limit, which is a finite number. And I want you to make a guess for what that is and fill it in this blank here. I want to have you pause the video for a quick 15 seconds to make a guess for that limit. In 3, 2, 1, pause and make a guess. Okay, so hopefully you did that. It turns out that they converge to 2. Okay, so weird. This infinite sum somehow just adds up to 2. Well, I also want to give you a more kind of conceptual reason why this is 2. So to do this, I'm going to draw a number line. I'm drawing a number line, and I'll put a tick mark at 0, and halfway at 1, and then at the other endpoint at 2. So the first number in the sequence is 1. That just means I'm going to go a distance of 1 on my number line. And then I'm going to add 1/2, which means I'm going to go 1/2 here. 1/2, that puts me here. And then I'm going to go a quarter. This remaining distance is 1/2, but if I go a quarter, I'm going half of that remaining distance. Now this remaining distance is a quarter, but I just get to add 1/2, which is 1/2 of that. Okay, when I did 1/16, that would go 1/2. And then I'd go 1/32, which is halfway. And I keep going halfway and halfway and halfway. And as I do that forever, the limit of this, I'm getting infinitely close to 2. And that's what my sum is. So that's a more conceptual reason why this infinite sum, actually, not only does it never go past 2, but it gets infinitely close to 2, and that's why we say the limit is 2. Okay, so what's the general definition? A series is this infinite sum. I get these terms a1 plus a2 plus a3 and so on. I can write that in sigma notation. To figure out what it converges to, if it does converge, you look at the sequence of partial sums. The first partial sum just has the first term. The second partial sum has the first two terms added together. Then it's the first three terms added together. And I could keep going. And when you look at this sequence of partial sums, if that limit equals some value L, then we say the series converges to L. But if that doesn't happen, because sometimes these limits either end up being infinite or they do not exist, then I say the series diverges. Okay, so that's a quick overview, but I want to end the video by briefly looking back at the example that we just did and clarifying two key things, which is if I just look at the individual terms that are being added up, just as a list, 1, 1/2, 1/4, 1/8, those terms get smaller and smaller and smaller, and their limit in and of itself is 0. Like these individual terms are getting closer and closer to 0. Like eventually the terms that I'm adding up are just getting really, really, really small. Like they're just so small. And conceptually, because the terms of adding up eventually are so small, that opens up the possibility that the whole sum could be finite. What does it add up to to figure that out, I'm looking at the partial sums. Like the first term by itself was just 1. The first two terms added up, that gave me 3/2. The next one was 7/4, and then so on. Those things, their limit ended up being 2. And that is what we say this infinite sum ends up equaling, just 2. So there's this distinction between just the individual terms of the sequence by themselves not added up. They got closer and closer to 0. But once I started adding them up, the sequence of partial sums, that got really close to 2. So over the next couple of videos, we'll look at some special examples of series. There's something called a geometric series and something called a telescoping series. So we'll talk about what those are.